Money is what we use to exchange for different goods and services. Money is paper, and each country designs their currency as little pieces of art where they emphasize what's important to them. Current economic system is set up where you can take the money that you earn, put it into a type of investment, and then over the course of time be paid compound interest, where the value of that initial investment is going to grow exponentially in theory. You can see that in the beginning, not much is happening in terms of the growth rate, but the key to compound interest is the length of time in which you leave it there. You can see in the later years how it starts to grow a lot more rapidly in theory. So that's what we're going to take a look at today, is how does compound interest work and how can you calculate it? This is a formula that we can use to calculate the value of your investment into an account where compound interest is paid. Think about what we know about exponential functions. We know that this is the y-intercept, so when time begins, when x is 0, that's the amount that you initially start with. So P in this case stands for principal, so this is the initial amount of money that we put into an account. And then we know that with an exponential function, the B represents the rate of growth or decay. In this case, because we're being paid interest, we're growing our investment, so we take 1 and we add it to that interest rate that we're going to be paid. And the reason we add on that 1 is that preserves the original amount, and then we add on the interest. So this I here is the interest rate that you're paid per compounding period, and you have to calculate that value. You're going to take the annual interest rate, annual means yearly, so how much interest are you paid per year, and you're going to divide that by the number of compounding periods per year, and we'll take a look at how to do that in a second. N we know is generally the x variable. In this case, this is the amount of time. We're looking at what is the total number of compounding periods that we are going to leave our money into that account for. And again, that's a value that we have to calculate. So we're going to take how often are we compounding per year, and then we're going to multiply that by the number of years we're leaving that money in that particular investment. When we put those values in, we're going to end up with the final amount of money that we have. So A stands for the future value. How much money will you be paid after that interest is calculated in there? One thing you have to remember is we always calculate I, we always calculate N. N is not the number of years that it's in there. N is the number of compounding periods. So it's how many times are you going to be paid interest over. There is simple interest and there is compound interest. With simple interest, you're going to put your money into an account, and at the end of, let's say, 1 year, they're going to calculate how much interest did you earn in that year. 10 years later, if we take that same principle, they're going to calculate how much interest did you earn per year, and it's going to be the same as year 1. With compound interest, at the end of year 1, they're calculating how much interest did you earn, then they're putting that money back into your account, and then in the next year or the next time period, they're calculating how much interest did you earn on the initial principal and the interest that was already in there. So it's basically you're being paid interest on top of interest, and that's what causes it to grow exponentially. We want to be familiar with the different types of compounding periods that you may encounter. We're going to start with annually. So annually means once a year. So you're going to be paid interest 1 time a year. So this is the only time where you can actually put that interest rate in for the I value. It is just I. And then N, remember, is the number of compounding periods. So if we are compounding once a year, multiply that by the number of years you lock that investment in for, and that is the value of N. Semi-annually means you're going to be paid interest twice a year. If you go down to the formula, we know that we calculate I by taking the annual rate and we divide that by the number of periods per year. So whatever your interest rate happens to be, we're going to divide that by 2. And then N is the number of periods per year. So in this case, we're being paid twice a year. And then we're going to multiply that by the number of years we leave the money in there for. Quarterly is 4 times a year. Think 4 quarters makes a whole. So to calculate that I value, you're going to take whatever that annual interest rate is. You're going to divide it by 4 because there are 4 periods that they're breaking the year into. And then you're going to say 4 periods per year, multiply that by the number of years you leave your money in there for, and that gives you the N value. Monthly, how often does that occur per year? Well, we know there's 12 months in a year. So to calculate that I value, take your annual interest rate, divide it by 12. To calculate the N value, there are 12 periods per year. And again, we're going to multiply that by the number of years you leave your investment in there for. Weekly, there are 52 weeks in a year. You're going to take your annual interest rate, you're going to divide it by 52 to get the I value that goes into the formula. And then number of compounding periods, if it's compounding 52 times a year, you multiply that by the number of years that it's in there for. Daily, there's 365 and a quarter days in a year, but we're just going to go with 365. We're going to take the interest rate, divide it by the number of compounding periods, and then again, it's that 365 times the number of years. Now, incidentally, in this day and age, I don't think you're ever going to see compounding daily or compounding weekly. The most common one that tends to come up is quarterly. So that's the one you're going to probably see most often. Remember, the two values you have to calculate before we can use that formula are the I value and the N value. So we're going to practice doing that first of all. The interest rate you're getting per period, per compounding period, is the I. The number of compounding periods is the N. So we're just going to practice calculating those two values. Let's say your account is going to pay you 11% per annum. So that's 11% per year. You're compounding quarterly for 3 years. So the first thing you're going to always do, and you can even take a highlighter, is highlight what is the compounding period that we're going to be investing for. And then we're going to say, okay, so we're going to take the annual rate of interest and we're going to divide it by how often we compound. Quarterly is 4 times a year. So 11% divided by 4 is 2.75%. Now, when it goes into the formula, it goes in as a decimal. So you're going to divide that by 100 to get it into a decimal, which gives us 0.0275. That is the value of I you would then put into your formula. To get the value of N, we're going to take how often are we compounding per year? Quarterly is 4 times a year. And if we leave the investment in for 3 years, which is what the question says, that means that we are going to have 12 compounding periods in the 3 years that your investment is in there for. Okay, so let's try the second one. So 6.5% per year, compounded semi-annually. So first thing you're going to do is really pick out what is the compounding period and highlight that. Semi-annually, you can refer to your chart. We know that's twice a year. So to get the interest rate, we're going to say, okay, take that 6.5% and divide it by the number of times we're compounding per year, which in this case is 2. 6.5% divided by 2 is 3.25%. And again, we're going to change that into a decimal. Divide it by 100 and we're going to get 0.0325. And again, you do not want to round this off. Keep that as the exact value. That's the number that goes into the formula. N is how often are we compounding per year? So in this case, we're compounding twice a year, and we're leaving the investment in for 2 years. So you're going to have 4 compounding periods over the course of that 2-year investment. All right, pause me. I want you to try the last one, and we'll make sure that you're able to do this. Okay, in my last example here, we're compounding monthly. We know monthly means we're compounding 12 times a year. Take that annual interest rate and we're going to divide it by 12, the number of compounding periods, which gives us 1.3% that we're getting paid for each compounding period. Change that into a decimal to put it into your formula by dividing by 100. And then N, if we compound 12 times a year over the course of 2 years, means there are 24 compounding periods in which we will be paid interest for. First example, we have $5,000 that we want to invest. That's our principal, our starting amount. The current interest rate is 6% per annum, or 6% per year, over the course of 3 years. We are going to figure out how much money we can earn if we compound in different time periods. So I'm going to do the first one for you, and then I'm going to see if you can do the rest of them. So remember, we always need to calculate I, and we always need to calculate N. So let's begin with I. If we're compounding annually, that means once a year. This is the only time where the interest rate is going to be the same. If we take 6% and that occurs once a year, then 6% divided by 1 is still 6%. We need to put that into a decimal, so we're going to divide by 100, and that is the value of I. The value of N, we are compounding one time a year, and we're going to invest for 3 years. So the number of compounding periods we have is going to be 3. Once we have those two values, we can substitute into the formula to determine our final amount. So we're going to put in our $5,000 principal. Now, I would not ever write 1 plus the interest rate. Let's just add them together. So 1 plus 0.06 is 1.06. And to the power of 3. Now the variable is already isolated, so you're going to just type this into your calculator as is, and because it's money, we're going to round to the nearest cent if we need to round, and we will end up with $5,955.08. That's not adding anything new to the principal. So if you just put that money into an account that pays that interest rate, 3 years later, you don't touch it, you will have gained $955.08. I want you to pause the video and calculate the amount of money you would earn compounding semi-annually. And then I want you to also take the same amount of money and compound monthly and see how that compares. Semi-annually, we're going to calculate the I, so we still have a 6% interest rate, but now we're compounding twice a year. So we're going to divide by 2, which gives us 3% per compounding period, which we can then change to a decimal. The number of compounding periods, we're compounding twice a year over 3 years, which means we're compounding 6 times. We put that 6 in for the exponent, we add 1 to the interest rate, and we're going to end up with $5,970.26. So you can see by compounding more often, we are earning more money. In the first one, we earned $955. Now we're up to $970. In the last example, we compound monthly. So take your annual interest rate, divide by the 12 months. So we're compounding 12 times a year, and then change that value into a decimal. If we compound 12 times per year over 3 years, that means there's 36 compounding periods, which you can then put into your formula. And you can see in this case, we're going to end up with even more money. So what I want you to see here is it's the exponent that ultimately makes the difference in how much money you earn. The more often you compound, the more money you're going to be able to generate. The last example that goes with this question is now we're going to look at how long it will take to get a value of $6,200. This is now the final amount that we're trying to reach. We're compounding monthly, which is the same thing we just calculated here. So we already know what that interest rate is, and we're looking for N, that is how long. So when we go to do this, we can substitute in that $6,200 in the place of A. Our principal is still $5,000, and we just calculated the monthly interest rate, so we're going to put that in as 1.005. We're looking for the value of N. So I can solve for N by graphing this. I'm going to enter this as Y1 into my calculator. I'm going to enter this as Y2, and I'm looking for that X value, which in this case is going to be the value of N. Now, when you put this into your calculator, remember that this is a horizontal line that's going to cross the y-axis at 6,200. So I want you to try to enter this into your calculator. You're going to have to change the window and make sure it's going to be higher than that. And we have a growth function. We're going to be rising to the right. So choose a window you feel is appropriate. And then I want you to try to get the value of N. All right, so going into y equals, I entered the two sides of my equation. Remember, we're going to go exponent and then the variable. And then I had to adjust the window. So these are the values I chose. I know I need to be higher than 6,200 on my y maximum, and I moved the x maximum over enough that we will be able to see the point of intersection. When you go to graph it, you might have to adjust from there, but in this case, I can see where they cross. So we're going to go second function trace, number 5, and once again, just move your cursor close, enter, 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 and the value of x is our solution. So when y is 6,200, x is that 43.1297, etc. Okay, now it's really important to remember that value, that 43.1297, is the number of compounding periods. We want to know how long we're compounding. Now, it doesn't say what unit they want us to put the answer in, but oftentimes it will, so you need to pay attention to that. If the question, for example, wants to know how many months that is, well, we're compounding monthly, so it would just be 43 months. If it wants to know how many years that is, well, we can take the amount of months, divide that by 12, and we want to keep the exact value here. So if I go second function answer, it's going to put that value in there, my last solution that we calculated on the graph. I'm going to then divide this by 12. And when I divide that by 12, I can see it's going to take me almost 3.5 years. If I want to turn into the exact number of months, let's take off that 3. And when we do that, we're going to be left with that portion of a year, and then multiply that by 12, and it will give us the amount of months. So it's going to take about 3 years and 7 months to reach that value. I just went ahead and wrote this on the side here so you can see what we're doing. So depending on what unit of time they want you to put the answer into, pay attention. How often are we compounding? Remember, n is the number of compounding periods. So it's going to take 43 months to reach that value, or you can see that if we divide by 12, we can put it into years. We know it's 3 years and a portion of a year. So I just took that portion of a year. We know there's 12 months in 1 year. Set up a proportion, cross multiply, and when we do that, that's what's going to give us that approximately 7 months to get to that value. Compound interest will produce a growth function, but we can also have something that loses value over time. If you think in terms of things that you own, vehicles and technology are the two items that tend to depreciate the fastest. The minute you drive that car off the parking lot, it starts to drop in value. So when we're trying to calculate how much of something is worth as it loses value over time, we know we're going to have a decay function. I'm going to use the same formula, but in depreciation cases, n is going to be the number of years. I is going to be the annual rate of depreciation. So we're looking at over the course of a year, how much value will it lose? So depreciation is a little bit easier because we can just put that value in there. Okay, so you're going to put your name here, and I want you to think, if you don't own a vehicle, how much would you be willing to spend on your first vehicle? And I want you to put that amount here. So let's say, put $2,000 in. If I am losing 20% a year, I'm going to subtract that 20% from my 1. Now, you can also think about it and go straight into this. If I am losing 20% per year, it means I'm keeping 80% of the value. I know it needs to be less than 1 if I'm losing value. That's what gives me that decay function. So we can just put this into our calculator and calculate that after 3 years, my vehicle is almost half of what it was originally worth. Then we can say, okay, how many years is it going to take until we hit a value of, and again, you can put a number in here that you'd like to try out, and I want you to see what you can do. So I just did $500. And so I put in, this is my final value I want to get to. I started with $2,000. I'm keeping 80% of the value each year. I'm losing that 20%. And I'm looking for the number of years that it's going to take to get there. And because it's depreciation, this will be the number of years. I put this into my calculator. So on the left side, we entered this as Y1. We entered this as Y2. We looked for that point of intersection. And it's about 6 years from now, my car is going to be worth, that particular car, a quarter of what its original value was. When you have a job, you're going to get paid for the work that you do. That's the exchange of labor for money. You can take some of that money and invest it into an account where you're going to start to grow your money over time, so that as you're older and maybe don't have the ability to work as much, you still have some savings in your bank account. You can also spend more money than you have by putting it on a credit card. If you pay that credit card balance off at the end of every month, you will not have to pay interest on it. But if you do not pay that balance, you're going to be charged an interest rate. And credit card companies generally start around 18, 19, 20%, somewhere in there. I'm going to assume that we have a credit card that's charging us 20% interest. Now, you have to make a minimum payment every month, but that minimum payment is very, very low. I just assumed for the simplicity's sake that we made $2,000 worth of purchases and we have a 20% interest rate. So that's that 20%, but we're keeping that original $200 and then adding the 20% interest to it. If I don't pay anything, if I don't pay the minimum balance just for simplicity's sake, the next month I owe $240. That's buying nothing new. That's just adding the interest on. Then they're going to do the same thing. So I'm not purchasing anything else, but now we're going to again assume that same interest rate. Now, 2 months later, I owe $288. They're going to calculate the interest rate, add it on, and the next month I'm going to pay interest on that. So you can see 4 months later, we've over doubled what we originally owed, and we haven't made any more purchases. That's just not paying off the original amount that we had. So a credit card is going to charge you interest that's going to compound how much you owe. Savings is not going to be quite as high of a percentage that you're getting back, but it's also going to, over time, compound your interest rate, assuming the economic structure that we currently have. I would strongly encourage you to track your spending. What do you currently, or what did you currently used to spend a lot of your money on? Are there places where you can start to get $5, $10 and save that money? No matter how little of an amount it is, it's those habits that you want to build. Take that money that you may have spent in other places, and you don't have to cut back entirely, but look at what are you spending? Could you get some money and start to invest it so that over time you can put that concept of compound interest to work for you, and then start to grow your money so that as you're older, you have a more financially secure future. And again, that assumes that the economic structure stays as it is. You want to be someone who is financially literate and understands your own personal finances, as well as to have an understanding as to how the banking system works, how money works, and what your different options are, especially as you move into adulthood.